All right, so today we're going to continue our basic derivative rules, just more about applications. So our first one's kind of a little fun little question right here. It says, sketch the graph of a function so that f prime is less than 0. And for all functions that the rate of change of the function is increasing. So the first one, of course, says f prime of x is greater than 0. Well, less than 0, I'm sorry. So, of course, this is saying that the slope is, of course, negative. And then we want to find out that the rate of change of the function is increasing. So this is saying that the change in slope is increasing. This is a tough question right here. Now, if we think about this, in terms of physics, we can think of the slope as being the velocity. And the change in slope, that's right here, as the acceleration. So there are a few options we could have. I can have a graph looking like this, or like this, where we're always going to draw these little curves. All functions have the same basic curves. And the next one, like so. If we look at the first one, here we can say, what can you say about the slope? Well, we have a negative slope. But if you notice, I'm going from a negative slope, and it is getting larger. So we can say slope is increasing. Over here, oh, look at the slope. This is always a positive slope. But as we continue to the right, notice the slope is getting steeper. So the slope here is also increasing. Now there is a relationship with what we call the concavity. Notice in both these, the slope is increasing. For our next one over here, same idea. The slope here is positive. But as I move along to the function, the slope is getting less steep. So here we could say the slope is decreasing. Over here we have a negative slope, but again, the slope over here is also decreasing over time. It's getting steeper, but in a negative direction. So we say slope is decreasing. So we want where the slope is negative, but the change in that slope is increasing. So this is the one that we want right here. We're going to talk about this later on differentiability, so we're not going to worry about that one for right now. But let's take a look down here. We want to talk about applications of the derivative. And this is one of those find a, b. So this is going to be our system. We're going to have to create a system of equations here. And we saw a question like this last unit where we had to find out if it was differentiable. And we said, remember, differentiability implies continuity. So the first thing we do is we have to show that the function is continuous. Continuous. And remember the value, first of all, a thumb. Does the value exist? And that's going to give us, if I plug it in, 4a plus 1. Step 2, we had to check the limit. So we take the limit from the left, see if that equals the limit from the right. From the left, that's our less than symbol. And that's going to become ax squared plus 1. And on the right, it's our bx minus 3. Plugging in, we get 4a plus 1 equals, plug in here, 2b minus 3. It doesn't really solve for us, but I can rewrite this as 4a minus 2b equaling negative 4. And you can reduce that if you want to. So there's one equation. So now we're going to check the derivative. Now beforehand, we had to use the definition of our derivative. In this case, we actually don't have to, because we know our shortcuts. We need to take the derivative on the left and to see if that's equal to the derivative on the right. So let's take their derivatives. Well, what would f prime of x equal? It's a piecewise function. So for the first one, we would get 2ax. Now be careful, x is going to be less than 2, not equal to 2, no endpoint. And the reason for this, it is not less than or equal to 2 because 2 is an endpoint. Okay, so remember the derivative cannot exist at an endpoint, so that's why we do less than or equal, just less than. The derivative over here in the bottom, b is just my constant, we just get b, and that is x is greater than 2. So the derivative on the left is just going to be 2ax equal to b, and we're going to plug in at x equals 2 because that's where we want to find it at. I plug it in, I get 4a equal to b And I can just substitute in. Sub in. So I can now say that, what does that become? If I say 4a is b, I'm going b minus 2b equals negative 4. So we get b equals, what's that become? 4. And if b is 4, therefore a is, what's that going to be? 1. Right there. And there's our answer. Very easy to do these. Very easy. Okay? Alright, so let's go and take a look at what some of the most important concepts in math right now is average rate of change versus instantaneous rate of change. Okay, the average rate of change of a function, or what we like to call Iroc, on a domain f of b is given by f of b minus f of a over b minus a. This should look familiar to you. This is the slope of our secant line. So real simply, like if I have a function right here, and I have a and b, here's f of a, here's f of b, might not be drawn to scale right there, I can find the slope of the line containing them. That's the slope of our secant line right there. This is sometimes what we call average velocity. Now, it requires 2 points. Next, we have what's called instantaneous rate of change, which we call Iroc. Now, Iroc is f prime of c. This is the slope of a tangent line, and it requires only 1 point. So if I have a graph, same idea, if I have a graph right here, I can find the slope at x equals c. That's the slope of our tangent line. And we talked earlier about why do we call it a tangent line, right? Well, this line right here, it has a change in x and a change in y. The slope is change in y over change in x, which is the tangent of an angle. And that's what we call it, a tangent line right there. Alright, so let's try this out real quick. For question 2, it says we're given this function x cubed minus 3x squared plus 4. We're asked to find the average rate of change of f on this interval. So they're telling me here's a, here's b, and then find the instantaneous rate of change, Iroc at x equals 3. So let's deal with Iroc first. I don't know, my computer's a little bit slow. Okay, so if I want to find the slope, the average rate of change, my rule says Iroc is f of 5 minus f of 1 over 5 minus 1. So I need f of 5. I'm going to go and do that real quickly here. If you plug this in, what you're going to wind up with at f of 5 is 54. F of 1, if you plug that in, 1 minus 3 is negative 2 plus 4 is, what do we get? Negative 2. Sorry, plus 4 is 2. There we go. So I can write this as 54 minus 2 over 4, which becomes 52 over 4. And you're going to leave that alone. Okay, now one thing I want to tell you. I want to see this. This is worth 1 point. Okay, you need this step right there. Show f of b minus f of a over b minus a. The AP will always give you a point for that. Okay? So there's our average rate of change. Well, the instantaneous rate of change, we want at 3. Okay? Well, think of it. What's 5 plus 1 is 6 divided by 2 is 3. So we're looking for the average rate of 3. So to find the Iroc, we need the derivative. So that is the derivative f prime of x. So f prime of x equals, what's that going to become? 3x squared minus 6x. The 4 just goes away. And I want to find f prime of 3, and I can plug that in. 3 times 9 minus 18, and we get, what's that, 9. Where this is an average slope, right there, or an approximate slope, sometimes we say, an approximate value, this is the actual slope itself, or the actual value. Alright, go on to part 2. We're going to answer 2 more questions right here, okay? Bye-bye.